So for this example, it introduces us to the Doodad Company problem, and it states, the Doodad Company makes widgets and gadgets. Each widget the company produces will result in a profit of $2. Each gadget produced will result in a profit of $2.20. Each widget requires 5 minutes of machining, 1 minute for painting, and 2 minutes for assembly. Each gadget requires 4 minutes of machining, 5 minutes for painting, and 3 minutes for assembly. During any given workday, there are 164 minutes available for machining, 100 minutes available for painting, and 74 minutes available for assembly. Determine the objective function, expressed as x and y, of how many widgets and gadgets should the Doodad Company make per day to maximize its profit. Now, this type of problem is known as a linear programming problem. They're also called optimization problems because we want to have the best output. And linear programming problems typically consist of two things: an objective function and then a series of constraints or conditions that puts limits on the objective function. An objective function is a linear equation that we want to specifically target or highlight. It's typically the basis for the entire problem. These equations express an outcome that we want to optimize. And these outcomes are typically expressed as profits or costs. P would be for profits, and we can use C for costs. Profits we typically want to maximize. We can see right here we want to maximize its profit. So if we let P equal profit, we can see right here $2 for every widget that's made and $2.20 for every gadget that's made. So if we let X represent the widgets, then if we do 2X, then for every widget that's made, the company's going to profit of $2. And if we let Y be the gadgets, then for every gadget that's made, the company's going to make $2.20. We could just do 2.2 Y. And of course, the idea is to determine how many widgets, X, and how many gadgets should be made in order to have the most optimum or maximize the profit. But P is equal to 2X plus 2.2Y is the objective function that models this problem.